Hey everyone, good to see you. What we're going to do in this session is we're going to go through a whole bunch of ideas. And the purpose of this is to just like spice up your mind in terms of what are the kinds of things we're going to be considering this week. And there's a whole bunch of things here that many of us have been working on for many years, have been planning. Some things are new, and so on. So quick disclaimers. This presentation is a big survey of things I think are important to work on. This is not exhaustive. Many things did not end up here. I'm working on some of these things, of course, with other people and across many different teams. So if I'm working with you on some set of things and you're like, wait, what about this other thing? I'd never heard of that. Yeah, well, there's a big ecosystem. One other disclaimer. I've been working on Falcon for about 10 years now. So I've been thinking about this kind of stuff a lot longer than others. So I have a very large amount of interconnected opinions. And that means sometimes I can see something and I don't quite know why I'm seeing it. And so asking me questions is good because it helps elicit that out. And other times there's some nuanced thing that we should not forget about that like we need to document somewhere. And I have done a terrible job of documenting. So you asking questions will help me express that. Many of these things that I'm going to discuss here are very far away from being FIPS. And I am looking for FIP co-authors to take those and turn them into FIPS. So if you're interested in taking some of these and working with me on those, come talk to me afterwards, and then we can maybe write a FIP together, which would be awesome. Timing. I think a lot of these things could be done in the next 2 years. So they're not like next 6-month things. But they're also not next 5 years things. I'm tuning this to be kind of like next 2-year things. Now, if we manage to do all of the things that I have here, that would be very surprising, and it would be awesome. Unlikely. And some of the things here, especially POREPs and proofs of location, will likely take longer, but I would love to be surprised. Cool, let's get rolling. So I'm going to start with like the working backward section from last time. I'm going to assume that everyone was here. If not, if you're watching this in video, pause, go watch the other talk that I gave before on Filecoin vision and this working backward section, which is how we got to that table, which is the constraints that we're going to try to meet, and the list of things that Filecoin should likely be able to do. I'll read them off quickly. Storage and boarding needs to be able to scale to zettabytes. Writes of all sizes need to be able to go into the network. Kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes. You should be able to have a client bring in an exabyte, and that should be fine. You should be able to have write aggregation, buckets, collections, and so on. We should have mutable writes. We should have reads of all sizes. We should have reads with very low latencies. 3 milliseconds if you're in the same data center. 30 milliseconds if you're nearby, 100 milliseconds if you're like in the same rough continental region, 300 milliseconds around the world, and 1 second for like that, kind of coldish, lukewarm storage. We should have storage media of all types in the network, so we'll get to that in a moment. The chain must scale. Good news, we've been working on that for many years. We should have partition tolerance, and we should be able to make storage certifications verifiable, provable claims. So there's a whole swath of things. New POREPs, deals must be of any size, composable deals, aggregators, and so on. So we're going to dive into this in a moment. Cool. So let's go. I lifted the scaling Falcon one up to the beginning because this one, once you see this one, then a bunch of other stuff becomes easier, like dramatically easier. This is why we heavily believe in the IPC direction, and why we've been working on it so hard for a long time. It's very near and dear to my heart. I've been working on this since like 2016 initially. It's one of those ideas where like, oh, we can do this, then file it away for like 5 years or 4 years, and then eventually come back to it. IPC was previously called hierarchical consensus because the idea is that you create a tree of blockchains to give you both horizontal and vertical scaling, which is really neat. Taking a single blockchain, you can hang on any subchains from it, and you can recurse down as far as you want. It's a full chain. It's not a rollup. So that means it has its own data availability layer. So it does not need any other extra stuff. And it means that it should have a tool suite that can handle block explorers and all of that kind of stuff. So IPC is a whole protocol and software stack that enables us to create these trees of subnets or these trees of chains. Each chain can have child subnets. Each subnet is a full chain. Each subtree can be available through partitions. So this is a constraint, like some subnets may not be able to do this, but we should be able to get there where an entire subtree should be able to disconnect from the rest of the network for a period of time and then come back after a partition gets healed. And you should be able to regionally constrain subtrees. This is going to become really important. This is what lets you do very fast block times. You should be able to add more subnets as you go. You should be able to do recurse deeper if your block space becomes too expensive. Regional subnets can give you super fast block times because the block times are limited by two main things. The verification speed of when you're computing something and the diameter of the network that you're trying to propagate the information through. That second one is speed of light problems. So you can't go faster than the speed of light yet. And certainly you're not going to do it to move around some transaction because that would be a very, very expensive process. But you can shorten the distance you must travel by reducing the size of the network. So if you make the subnet be just the size of a continent or a city or a single data center, then you can greatly decrease the block time. So that's kind of the insight. It's just a very standard 1950s server systems idea that can help us scale blockchains. Cool. So using IPC, we can then give Filecoin regions like the cloud. So we can have one subnet per region. And we can even fan out deeper into zones. If you're familiar with availability zones in the cloud, that's just another subnet. So let's work through an example super quickly because this is going to be important the entire rest of the week, but especially this talk. So let's say we have the L1. It's the Earth chain. It's the mainnet. We have one network. And we have two subnets, two L2s, one in Asia and one in North America. We call them continent subnets. So now we have three subnets. Those two are separate chains that are checkpointing into the parent. You should be able to call across chains. You should be able to mutate any state in either one. Then you can keep going. You can recurse down to hang L3s from those, and those become your region-specific data center type subnets. Now, of course, you can fill out the rest of the continents, and you can go into the availability zones. And so here, that's an example of adding. This is replicating exactly what the cloud currently has, the standard region availability zone setup. And we did this with just a few subnets. Now, the tricky part here is figuring out the regional location question to be able to make sure that the validators are truly where they say they are. I'm not going to go into that now, but that's what it allows you to do to go really fast. So what does this mean for Filecoin? It means that you can have much higher throughput. So think infinite scalability level. You pay for it in terms of the complexity of the fan out and the cost. And you can have much faster block times. You can have partition tolerance and so on. And people ask, what kind of state should go on these subnets? Everything. Just move all of it. Move the storage miners, move the accounts, move the storage markets, move everything down. We have to think about and reason through how to do things like DeFi and DEXs and so on, because you don't want to have 1,000 different wrapped and unwrapped tokens. And so we have to get certain kinds of calling conventions to be fast enough. But this way you can move a ton of the state lower, drop the gas cost dramatically for those parties, and also speed up the processing, and then make certain features for other proofs much easier. So things like poor reps become much, much easier to do. Cool. Go ahead.
What's the cost or what gets harder? Because this all sounds fantastic, but must cover.
It's communication complexity of reasoning about the contracts calling other contracts, because you now have parallelism in the chain. Yeah.
Do you have some kind of eventual consistency?
Yeah, so you can think of it as eventual consistency moving across the chains. The neat thing of the tree You could design something like this that has no hierarchy, that is all kind of relative, but that's way harder to get right. And so the neat thing about the tree is that just certainty flows up, security flows up. And so if you want your state to be safer, you wait until the checkpoint is committed to the parent. You might wait until it's all the way to the root if you wanted that, and so on.
How do you stop it from getting blocked? If somebody drops off the network and never comes back,
So each of these groups is this full chain. So that should have a set of validators that are running it. And so if any one of them goes out, there should be a set that continues. Yeah, but good observation, which is that the security level of the child is always lower than the parent. And as you go further down, the security level drops. So because you have less and less and less nodes. And so you have to model that into the assumptions of the system. But this is how you can, if you think about local currency, you walk around with like cash or like credit locally, and you don't have like all of everybody's assets on them at one point in time. At the same time, you're not, waiting for like a bank vault to approve a transaction when you're trying to get a coffee or something. Cool. I'm gonna keep moving because there's a lot here. Data abstractions. This is stuff that a number of us really care a lot about. Currently, the deal abstraction is a single object for a single, very specific transaction. And it's not really a deal the way that most people think about it. And in fact, most clients never touch it. It's mostly in the data prep pipeline, and it's mostly storage providers. So what the current deal really represents is like a storage contract in a specific sector, and it's not a great abstraction. So we need other kinds of abstractions. We need things like long-running deals. I think of very long-term deals. We need mutable deals where parties can agree on certain terms, but they can change the actual storage that they represent. We need tiny deals. We need to be able to define agreements on tiny little objects. Think of object storage, S3 style. We need large deals that span much larger than sectors. So think of like terabytes or petabytes scale. We might need subcontracted deals where deals can be handed off across parties. We might need to aggregate deals. So that means we need to take multiple deals and pull them together into another deal. And we might need to be able to make deals on collections of objects. So we might need to refer to specific collections on chain, and we might need to be able to create deals on that. I'll get to that in a moment. So composable deals, I just sort of mentioned it, but think of a way of describing a deal and associating some metadata with another group of deals. So if I have an aggregator or something like that, and I'm making a ton of little tiny writes, and each time that I make a write to the aggregator, I'm effectively asking for that to be stored. It's like a little mini deal that should be tracked somewhere. And eventually that aggregator should be able to bundle all of that, wrap it all into a larger deal, and then give it to a storage provider or something like that. And so think of these as composable abstractions. You should be able to have an aggregator deal type thing that can refer back to all the little individual data structures. You might want something like a repair deal, a contract to maintain a storage deal of some sort. And you might want this to be abstract so you can connect it to any other type of deal. So you can task a set of parties with repairing and making sure that all of the data is replicated correctly. You might want a dispersal deal. I think I have another slide on that in a moment, so I'll leave it to that. I mentioned you should be able to have deals of any size. Currently, the deal size is limited by sectors. So the deal cannot be larger than a sector. I think we're starting to work on some of that, but it's not yet fully decoupled. It would be great to be able to fully separate what a deal is from what a sector is, so that each of them can vary in size independent of each other. Right now, they're kind of stuck together, and it sucks. You should be able to make small deals, huge deals, and so on. The hard part here is that it requires decoupling deals, sectors, the markets, and the proving tree. I know that Einarth and a number of other people have been pushing on a lot of this work. I think getting to full, super clean deal abstractions that are sort of composable still TBD. You should also be able to make deals of any duration. You should be able to have very long-term deals that are much longer than sector durations. Think of being able to express things like perpetual deals, or just kind of 10-year or 50-year type of things. This is similar kind of structure, and it does require figuring out how SPs would repack deals from one sector to another. As the sector expires, then move those deals to to a new sector. A dispersal deal, so there's a class of algorithms called information dispersal algorithms, which is a way of taking a little bit of data, expanding it not too much, like say 1.5 to 3x, chopping it up into little pieces, computing erasure codings, and then spreading that across a very large number of nodes. If you do this, you get an enormous level of resilience where like it's extremely difficult for that data to ever be lost. This is how large-scale storage systems tend to back up stuff. You could do kind of a dispersal actor on chain that could do this. Like you could point it to a deal, and they could like task a certain set of parties with like chopping up all of that into little pieces, dispersing it into a lot of storage providers, and then you can always resurface that whenever you need it. Know that dispersal is not good for retrieval. If you chunk a bunch of little pieces and erasure code them, it's really slow to bring it back. But what you get out of it is you get super high resilience without a lot of extra storage. You should be able to access control deals. It's something that a number of us want. You should be able to express a certain capability associated with a deal to express what other parties should be able to have access to that deal. Whether access might mean downloading the ciphertext, access might mean downloading a clear text, access might have the decryption key to be able to decrypt it. Thankfully, we have crypto capabilities, and those give us all of this kind of rich access control world. UCAN is a great standard that kind of brings the OCAP model into just useful modern web standards. And so now we can do that with deals, and we can now express super rich structures and have software and protocols obey the intents of the user. So for example, things like Boost and others could like learn how to use this. And protocols on chain could learn how to do this. Like you could have a UCAN associated with a data DAO, for example, and only parties that have the right capability could like write to that thing. And the neat thing here is that it gives you a much more expressive language beyond what standard smart contract verification would give you. It's just like and as long as the capability check is correct, then you're good to go. Cool. We should also have on-chain collections. So you should be able to track a collection of objects that is changing on-chain. You should be able to associate a large group of objects with in this kind of collection, and then be able to associate that collection with other things. For example, like a deal, or a perpetual contract, or something else like that. Collections have very well-trodden ground. There's tons of data structures that can support them. This lets you also connect that mutable set with access controls like UCANs and so on. And so we kind of need that abstraction to now live on chain. And so it'd be great to kind of like start creating some reference implementations of these to then start connecting them to other pieces. Buckets. So the most famous, or these days, the most famous collection in data storage land is a bucket, which is a very simple collection abstraction. It has a mutable set of objects. It has a file system hierarchy, so you have path names. You have access controls associated with that, and you have encryption usually. I think there might be a couple other features here, but that's basically what most buckets consist of. We actually have an implementation of a bucket set of data structures on IPLD already, which Textile built, called Textile Buckets. I don't recall what authentication it used, or whether it used authentication. I think it did. But this might be, now that we have UCANs, this might be great to mix with that and make fully portable. I don't remember what the underlying stack there is, but we should be able to grab all the Textile buckets and then connect them with on-chain data structures, which would be pretty sweet. Once we have these, collections on chain, you should be able to now create a deal for that mutable collection. So you can create a bucket abstraction on a chain. You could add stuff to that collection with an aggregator. And as you're adding stuff to that collection, have an associated deal that will continue storing whatever else you're writing to that bucket over time. And all of this should be able to just fall out of the data structures that we're talking about. Having these kinds of aggregator deals, having these collections, and then having a set of parties that are providing you that buffer where you can do the writes to then end up batched into storage providers. You should be able to, but it's a small nit. Currently, we call things pieces, and we tend to think of them as like connected to the deals. Turns out they're much more connected to the sectors than they are to the deals. The piece right now is the payload plus a very specific proving tree in a specific format designed against a specific POREP algorithm. So as we have more POREPs, each POREP will imply a specific proving tree, which will imply a specific piece. So the piece is really a part of the sector in a sense. So we should probably rename this to like sector piece so that we can specify which sector type they belong to, which specific POREP algorithm they're computed with. Cool. I think a lot of other people are going to talk about these, but here's something that a lot of the community has talked about for a long time, which is currently the role of storage provider is huge, and this should be broken out into multiple separate roles. Now, of course, many storage provider entities might want to continue doing all of it or continue only doing a subset. But either way, the protocol should evolve to be able to express these separate roles, to be able to do all of this kind of specific targeted work. Many storage providers out there only really want to do the core storage provider work, or maybe that plus data preparing or something like that, but they don't want to do a bunch of the other pieces. And so we need to create structures for all of these, and ideally incentives, to enable all of these different pieces. So storage providers, like the core storage provider work is just storing the data and prove long-term storage, allowing infrequent retrievals. Data preparers should turn client's data in whatever format it is, into the well-formatted sector pieces that are required for long-term deals. We have repair as a component, which is you should be able to notice, some set of providers should be able to notice that some piece has disappeared, be able to download it, reconstruct it, and post it somewhere else. Consensus providing, you should be able to, producing blocks in the chain requires different kind of hardware and different kind of connectivity than just storing the data, and separating this out might actually be extremely helpful for a lot of storage providers out there. Sales providers or something like that. There's a lot of SPs that are doing phenomenally great work talking to prospective clients, onboarding a lot of data, and talking about the benefits of the network, crafting solutions for them. That's a huge amount of work and of great value. That needs to be sort of like called out and explicitly modeled in the protocol, because it's super valuable. And there should be parties that could just specialize on that. Like they might not need to also do all of the storage providing. Retrieval providers, these ones have been broken out already, but I mentioned them for completeness. It would be great to have, we already have these separate high frequency, high bandwidth, low latency retrievals. And maybe a last one here is aggregation providers. So currently we have a bunch of centralized on-ramps. It'd be great to make decentralized on-ramps that have these kind of providers that can do this whole aggregation, that giving you a very high frequency small write endpoint to then batch these small writes into larger writes. We could use things like buckets or other collections. Once you kind of break these pieces out, you can then start creating markets for these components or creating incentives for these components or L2s for these, right? So for example, with retrieval providers, Saturn is going to be this sort of like L2 on top of Filecoin. All of these other ones, like aggregators and so on, could be their own L2s or could create markets. So there's a lot of possibilities here for really neat protocols. Cool. Here's the, I have 5 minutes left, so I'm going to blaze through. I'll leave a lot of the POREP in-depth discussion for another talk later, but I'll give you a feel now so that you have it in your mind as you go into other discussions that, hey, POREPs can actually change. Hey, first off, we have VDFs now. Let's try and create cheap POREPs with VDF hardware. We should be able to do latency-based POREPs. Let's switch the model from cost into latency. That'll help us drop the cost and should enable fast and cheap retrieval. The devil's in the details. Pretty freaking hard. A lot of us know that. However, this would be super, super valuable. You should be able to use VDFs and or IPC together to create pretty good latency-based POREPs where you can have a subnet and speed up the block time to be kind of like whatever speed you need to make the POREP really cheap. And so whether that's like a second, 100 milliseconds, or even 10 milliseconds in some crazy circumstances, that could be extremely good to be able to have very, very cheap POREPs. Optionally, you might have to use VDF to decrease the cost further or make it secure. This is kind of like for us to figure out. One thing that Falcon is going to have to evolve is the ability to enable different types of storage hardware media to come online using tailored POREPs for that storage media. So that means a specific POREP for tape, a specific POREP for capacity hard drives, a specific POREP for performance hard drives, and so on. So this requires new protocols. I don't think we're going to get to, or the POREP focus right now is on getting like at least one fast retrieval POREP, but if people are interested in other types of storage, this is the way to do it. Like you add a POREP for that storage media. So you just look at this table and you design a POREP for that specific location. So for tape, you look at that type of access pattern, that response time, and that kind of like frequency of access. For capacity hard drives, you kind of want to be there. For performance hard drives, there, and so on. We need other types of proofs in Filecoin now. So things like proofs of data possession to just show that something is accessible. For verifying unsealed copies, or proofs of retrievability to show that a party has access to some piece, but also provides the ability to retrieve the piece from it. These could be super useful with SPs, but also with retrieval providers to prove that the retrieval providers are indeed caching the content that they're promising to cache. There's a specific layer in Saturn called the L2s that sort of need these. Proofs of location. This is something that we talked about a lot in 2017, and we've kind of touched on it here and there. A lot of the algorithms were kind of lacking. The literature has advanced a lot, which is great. And we now, with subnets, are able to do different kinds of measurements. So we should be investing in creating a proof of location, which is this will give you a cryptographic way of checking that a specific party is near some other set of parties. Near in terms of response time on the internet. And so that gives you a resolution of like cities or countries. Countries, actually. Cities is extremely difficult. Or using potentially hardware and things like GPS and so on, which is like less ideal in a centralized network, but could be quite valuable for certain kinds of certifications. If you can do this for agents, you can also do it for data. So you can take a proof of location and wrap it with a check of either a POREP or a PDP or one of these things. And if you do that, then you can verify that the data is actually close to the parties. So that's how you can get a cryptographic guarantee that the data is where the SP is saying it is, and where the client requires the data to be by law. And so this would be an extremely valuable primitive to add. My guess is that we can build these proofs of location with IPC. However, there's kind of like a chicken and egg problem there, which is like, you kind of need a proof of location. Like, if you really want to do IPC super safely in a small region, you kind of need a proof of location. But there might be like a good protocol to prove there that you kind of reach some equilibrium. We need to be able to do retrieval checking at massive scale. So think of the entire data set of all of Filecoin. Currently, it's being verified in terms of the storage. So every day we prove that the stuff is there, but we're not checking that it's retrievable. We need to close that gap because right now, a lot of the storage isn't retrievable, and a lot of clients are very frustrated. So if we want Falcon to be really valuable and really successful and the economy to grow, clients need to be really happy about their storage, which requires the retrieval to be checked. So we need some kind of protocol structure, kind of like posts, that check retrievability. And we need to do this at scale for the entire data set. Saturn, we've talked about Saturn in the past. It's a network for high retrievability caches. It has this kind of like layered structure with L0s, which are the clients, L1s, which are this high bandwidth cache, L2, which is the local high disk cache, and then storage providers. It's kind of like the L3. You can use IPC to build Saturn regions. So you don't quite need them for most of Saturn, but for L2s, which is a local high disk cache in a specific location, you could use IPC for doing this. And either way, you can sort of track the membership of the nodes and so on. Certainly, once you make the network big enough, you don't want to pay huge gas fees to like add nodes, and so certainly you want to move down into this model. We have implemented most of the Saturn layers except L2s. L2s likely need some kind of proof that they are storing the data. So PDP or proof of retrievability would be helpful there. and you could use IPC. The last one here in this set is data availability. You should be able to do a data availability network with IPC by creating a subnet and doing the data availability protocol entirely in that subnet, giving you some kind of like horizontal and vertical scaling. Last but not least, upgrading Falcon Plus. So there's a lot of constraints and problems with Falcon Plus that folks are worried about. One important reminder here is that, as we were talked about earlier today, the decentralized cloud needs to be the centralized cloud. And for that, we need both new features and a massive cost reduction. The block reward of Filecoin is oriented towards useful data for achieving that cost reduction. So that's a critical component. What we need to figure out is how to adapt the Falcon Plus program and to evolve it with new kinds of mechanisms to close a bunch of the gaps and to clamp down on the abuse. But we can't remove it. It's fundamental to Filecoin. That's what Filecoin is. I'll give another talk later in the week about how you can't actually not have this incentive and not turn the network into a bunch of wasted work. So there's a strong argument there that if you don't have a strong incentive here, the network will become just a lot of useless storage. If you disagree, come to my talk and we can hash it out. So now it's really critical that we greatly decrease the abuse. So that means measurement and prevention. We need very hard and concrete disincentives to do this. The Crypto Econ Lab recently found and talked about how, hey, actually it's dominant. It's a dominant strategy to abuse, and like that's a core fundamental problem. So we have to close that. We have to remove that loophole. And so that means coming up with concrete disincentives for that. So like some kind of slashing or something like that. Now that's tricky. It's very difficult to figure out how to do that correctly. So I'm sure that as a group together we can figure that out. We also need more Datacap allocators. So that means there's a lot of problems that stem from the current specific. We have 3 Datacap allocators right now, which are kind of all nodar based at the moment. There's been a lot of proposals for new kind of allocators, things on chain, more decentralized protocols, all kinds of new ideas. These all fit within the model of Falcon Plus, which is just kind of a Datacap currency structure. So it'd be great to propose a bunch of these things, try them out, and as we see that they're working, then scale them. I see a lot of complaining about Falcon Plus and very little proposing of good structures that are actually decentralized. So let's figure those out, try them out, and scale them. Cool. So that's it. Bunch of ideas, some spicy ones, and yeah, let's hash them out this week. All right.
Thanks for sharing. Just a quick question about when you mentioned you have different zones. Are they all isolated? Completely isolated, or
yeah. So you want the block time to be very fast. So you want kind of like in an availability zone, which is like the lowest level, 4 layers down. You would probably want like a 5 to 10 millisecond block time. But I don't know. That starts getting into like verification limits. Cryptography is like not that fast. So 10 to 50 milliseconds block time. That would be great. Now we don't yet have that stuff proven out. We have to implement it. But we're kind of building the first layer down, and we're going to be, after we build the first layer down, we're going to experiment with the next layer down. So like think of the first layer down as maybe being like 1 second, and then after that like 100 milliseconds, and then so down.
So each, like the data from different zones, can they see each other? Like are there permission? Or?
Yeah, exactly. So you can associate a bunch of information with that particular zone, and you can express certain protocols that apply in that zone.
Okay.
Yeah. Something I didn't cover here is IPC gives you the ability to have like fully private subnets. So you can have a subnet that's either private by access, which is kind of like how you merge private chains with public chains, and you create this kind of environment that a lot of like the large scale corporations need. Or you can do zero knowledge chains or FHE chains, when an entire subnet is entirely encrypted, and you can have value moving in and out of that subnet, which is pretty cool.
Cool, thanks.
Yeah.
Hello, thank you so much. My name is Ilya from File Market. So my question is, are there right now any experiments regarding like data providers incentives layer that are going on right now already?
I think there were some experiments with like very lightweight incentives. I don't think anyone's made smart contracts yet, but I would love to see some smart contracts.
That's what we are doing right now, and we are applying for the grant now. So that's what I wanted to discuss with you, actually.
Awesome.
All right.
Yeah, I'm not the grants person, but I would love to check out the protocol.
No, I just wanted to tell you like the idea, like the basic idea, to share it with you. And we got some very cool corgis as well, like already a ready collection. I want to show them to you as well.
That's awesome. Thank you. And you also have great stickers, if I remember correctly.
Yeah, file finance, right?
Yeah.
Thank you.
Thanks.